My name is Krishna Chandran, and I was the lead for the Spatial Inequalities in Bengaluru theme as part of Peak Urban. This particular theme was motivated by the fact that in Indian cities, it's very difficult to understand inequalities at an intra urban level, like what's happening within the cities. Because on the one hand, you have census data, which is quite reliable and uh, you get it at the ward level. But then the wards themselves are very large in most Indian cities. In some cases, they are up to about 100,000 people. So wards can be very heterogeneous and so on. So to be able to understand what's the lived reality at the level of neighborhoods and households, one needs better granular data. The second thing is that other institutions within the city, like, say, for instance, the water utility and so on, use very different spatial units for their data sets. So if you have to combine population with one of these other data sets to understand, let's say, access to water, that becomes very difficult because your population is at the level of wards, whereas the water utility may use another spatial unit, like in the case of Bangalore, it's called service stations. And it becomes very difficult to reconcile between the two. Say, for instance, to understand a very simple metric like liters of water supplied per capita per day. Because this is something which you can understand at the city level, but then the city level aggregate hides a lot of variability which goes on within the city. So the first part of our research was really how can we disaggregate census data to have a much more granular understanding of what's happening within Indian cities. We took the case of Bangalore, and the way we approached it is it's based on the overall logic which has been tested in other contexts also, that houses or households which are of similar socioeconomic characteristics are contained or live in neighborhoods which are similar in terms of the build structure or the physical characteristics. So our line of approach in this was to use remote sensing and other geospatial data sets to understand urban structure at a very granular level, at a neighborhood level, in fact, at the resolution of 30-meter cells or grid cells, let's say, and use that to then statistically infer what population other parameters may be at this very granular level. So this was the overall approach, and using this, we first disaggregated census population data to generate a 30-meter resolution population data set for Bangalore. Now, what this also enables is that you can take this 30-meter resolution gridded population data and re-aggregate it to any spatial unit you want. For instance, if the water utility is using, say, the service stations, which are different from the wards, you can take the 30-meter gridded population data and aggregate it such that you get the population estimates for the service station, which then means you can take water supply data or bill metering data from the water utility and combine that with the population estimates derived from the gridded data to generate very accurate estimates of liters per capita per day water supplied within these service stations. So this was the overall structure of our project. We also wanted to go one step further and understand what are the drivers of the kind of inequality in pipe water availability, which we see within Bangalore. And this was supposed to be done through a set of more qualitative methods, including interviews with water utility officials and other researchers and activists in this domain. But unfortunately, that part of the project could not be implemented because of the COVID-related restrictions which came in. In terms of impact, I would say we have to look at it in two ways. One is the direct impacts, and then there are more long-term indirect impacts. The direct impact, of course, one of the most important things was we were able to build up a team of people from multiple disciplines who can work together on a problem of this nature and hopefully take this work forward. The second is we were able to put out several publications, of course, but also other tools and let's say software plugins and so on, which would enable some of this analysis in a much easier manner for other researchers. And these have been widely used in other settings because there are several other researchers who have contacted us regarding how to use it. And we also have metrics related to usage from online sources and so on. So these are, I would say, the direct impacts. The indirect impacts are those arising from, let's say, putting out these publications and these data sets and policy briefs and so on in the public domain, and how that then provokes further action, further research by other individuals and organizations.